Nobody likes boring games, right? Imagine you play a turn-based RPG, but you and your enemy always deal the same damage, so the outcome is predictable and the game is, well... That's why we introduce RNG and specific chances for different actions, meaning every round is different. You can only guess how the enemy reacts to your attack and what their response will be. The only thing we need to introduce such features is the built-in random library that comes with Python and some creativity. In this video, I'll show you my way of implementing damage range, missed attacks, critical hits, and counter. We'll build upon an already existing turn-based battle framework, the one that we created together in this tutorial. There will be some small challenges for you throughout the whole video, so if you don't want to miss them, be sure to watch from the start till the end. I'll link the repository in the description, so if you want to code with me, please go ahead and download it. You can do it either by simply downloading the zip repo to your desktop, or by cloning it if you have Git installed on your computer. Just make sure you're on the default branch, as I'll upload the end results to a different one. If for any reasons you want to skip to the RNG part and lose out on the fun of refactoring, you can download this branch instead. No hard feelings.
I double dare you, motherfucker!
Now, after downloading the repository, just simply open it in your code editor. As always, I use PyCharm. If you need some time, just pause the video, I'll wait for you. To those who haven't seen this project so far, here's what it looks like on a higher level. We have the main.py as the entry point of the game. We can start it from the console with Python main.py, or for some of us, we can configure the IDE interpreter. Then we have the character.py that includes the character-based class that we derive hero and enemy from. Each character object has a weapon and a health bar attribute that we construct from their corresponding modules. We spawn the hero with its default weapon, and then we can equip another one with the conventionally named equip method. Unless the enemies have fixed weapons, the ones that we construct them with. Although it's not necessary for them to work different in this example, yet this representation is closer to how RPG games work. Our primary focus is the character.py, but we'll slightly modify the weapon and main modules as well. Before adding any new features, we need to update the core logic of the game. Starting off, let's head to the weapon.py. For this example, I'll create two new weapons that our new enemies will use in combat. So far we have an iron sword, a short bow, and fists. Let's create jaws and claws as well, for enemies like wolf and such. All weapons have a value attribute, but we don't actually use it in this example. To type less, we can either remove it, or what's better, we can give it a default 0 value, so if the weapon has no value, we don't need to include it. Now that the weapons are ready, let's head to the character module and create a couple of enemies. I'll go with the stereotypical enemies as follows. Rat with 12 health and claws, Slime with 20 health and jaws, Wolf with 30 health and jaws again, Goblin with 40 health and short bow, and Orc with 60 health and iron sword. Now, we need a list of them that we can iterate through in the main module. We have a couple of options. Before I show you my idea, I'm curious how you would put them into a list. So pause the video and do it yourself. If you're ready, I'll show you a handy solution. If you chose this solution, it's not bad. Maybe it's the most intuitive one. Although, what if I don't want to add another element to this list manually each time I create an enemy? In order to accomplish this, our first step is to generate a blank list. This list serves as the container for any new objects generated from the enemy class. Therefore, we simply add the newly created object to this list within its own constructor method by using append. Now that we have a cool semi-automatic list that we can use to fight enemies consecutively, let's head to the main module and update the game logic. Before we import our new list, we should create a game class to have a better structure. What we had before will go to the run method of this class. It will have only one attribute, running. This will handle the flow of our game. Instead of while true, we can say while self.running. Then we can update this boolean at the end of each round. It will be the equation if health of the hero is greater than 0, meaning the hero is alive. We'll come back to this. After the while loop is completed, we should print something and quit the game. This is pretty minimalistic, but not for long. Now we can import our new list. What we need is some kind of factory-like method that gives us our next enemy from the list upon calling it. Again, I'll let you have this spark of creativity, so feel free to take the challenge and pause the video. Let's just continue. We'll have a spawn enemy method that we will call once before the while loop, and every time we defeat an enemy. Since it won't utilize any object level attribute, we can include the static method decorator and leave the self parameter. Static methods can be accessed without an instantiated object of the class. However, they can also be utilized at the object level, since the created object possesses this method, similarly to the class itself. This approach only works if the method doesn't require any attributes of the class inside of it. Of course, you can include the self parameter in this method, but it won't be necessary in this context. So, back from the technical stuff. This method will return an enemy object. But only if the enemy's list is not empty. If so, we return the first element. Let's also print some information to the screen and prepare the player for the upcoming fight. Now, if the list happens to be empty, it means we won the game. In this case, we can leave a message, then exit the application. Okay, but you could ask me, why we only return the first element? Or how can the list be empty? Well, this is part of the new logic. At the end of each run cycle, we should check if the current enemy is dead. If that's the case, we can remove it from the enemies list with the pop method, then spawn another enemy. This way, after a while, we'll remove each enemy one by one until we're left with an empty list, indicating our victory. Did you get it right? If yes, then fantastic. If not, don't worry. As you gain experience, these challenges will become much easier. To truly excel, you need 3 things: solid programming fundamentals, strong problem-solving skills, and a lot of practice. This is crucial. And that, my friends, is why I recommend Brilliant, the most innovative educational platform out there. Whether you struggle with traditional learning methods or just love engaging with interactive content, Brilliant is perfect for you. With Brilliant, you can master topics like math, engineering, and programming with just 15 minutes a day of fun, hands-on exercises. I've been using Brilliant recently to brush up on my skills, and I've been blown away by how much it enhanced my understanding, especially in areas I used to find challenging during my 5 years in university. Regardless of your skills, I highly recommend for you to try out their Thinking in Code and Creative Coding courses to boost your problem-solving skills, or dive into computer science fundamentals and programming with Python to solidify your programming knowledge, especially with Python. The interactive lessons and practical problems make learning so much more effective and enjoyable. If you're intrigued, why not start with a 30-day absolutely free trial or take the advantage of a 20% discounted annual subscription by clicking the link in the description. Let's make learning fun and effective again. Now, back to the video. This logic is totally viable now, but for a final touch, I'll put the screen clearing to its own method and call it when spawning a new enemy. Let's see the result. It works flawlessly. We're all set. Let's see the exciting stuff. First, I'll show you how we can implement a damage range instead of a fixed value. There are 3 different approaches actually. In our current design, we create new weapons by only passing a single integer as damage when constructing them. Although in the init method, we can create damage minimum and damage maximum attributes that we calculate from the input parameter. You can either do it with addition. This is viable for smaller values as it gives wider ranges. You can also solve this problem with multiplication. Just be sure to convert your values back to integers. This solution is better for higher values. If you want to have the most control over your damage, you can adjust the input parameters to accept minimum and maximum values and save them as they are. This way you can create weapons with exact damage ranges. Choose the one that you like the most and continue with that one. Just be sure to pay attention to the extra argument if you chose the last one. I'll go with the first solution now. Notice how we removed the damage attribute of the class. That's bad, since we used it somewhere else in the code. So if you started the game now, it would definitely crash. What is the most convenient fix for this issue? Got any guesses? Well, besides attributes and methods, classes have properties as well. If you haven't seen or used properties yet, they're like the mix of attributes and methods. While methods handle actions, properties are responsible for handling states of the object just like attributes. We create properties same as methods, but we decorate them with property like so. As for damage, we want to return a random value somewhere between the minimum and maximum values. For this task, we can use the randint function from the random module. This way, when we say weapon.damage, we get a random integer between its minimum and maximum damage. Just be cautious when using properties, as they need to be referenced just as attributes and not called as methods. Now, if we try this, we should see random values flying around. Okay, all good. Now, let's head to the character module and see what we can implement. First of all, let me fix 2 things to make our code more professional. Once, we can indicate the type of the health bar attribute of the character object. That is, health bar from the health bar module. We can also inherit the character class from ABC, meaning abstract class. Doing this prevents anyone from creating characters from this class, as this is an unwanted behavior. We only want to instantiate heroes and enemies from their corresponding subclasses. The next thing to set up for RNG is to include new init parameters and attributes for the character class. These are evade chance, crit chance, armor, and counter chance. Although for the variety of functionality, I'll use counter chance on class level with the value of 20. I save the other parameters as attributes of the object. For the hero subclass, I'll fix these values. As for the enemy, I want to pass them manually for each of them. While we are here, let's update the enemies with these values. Since it starts to get less readable, we can use keyword arguments instead. I know it's tedious to write so much, so feel free to grab this part from the description. The last thing to update here is this part. We will link this to the target instead of the attacker. This is not necessary though, rather just a style preference. Although separating this to another method is beneficial as we'll only need to update the image argument later. Back in the attack method, we can call this while passing the image and the attacker as arguments. Now that we kinda know how properties work, I have a quick challenge for you. Create a property for the character class that tells us if the character is alive or not. Pause the video and give it a try. Just like with the weapon, we create a property but we name it alive and it will return a boolean. That is the equation between the health of the character and 0. If it's above 0, the character is alive. Otherwise, it's dead. Good job if you figured it out yourself. Now we can use this property in the attack method and in the main module as well. The next RNG feature to implement is missed attacks. Ever since I started Gamedev, I always linked missed attacks to the target as it highly depends on its agility. But that's just my choice of design. Now we have a number to calculate missed attacks. Let's wrap it in a method. Similarly, like the health property, this will return a boolean, indicating if the attack missed or not. My technique to roll for different events is using the random function between 1 and 100. Each number has 1% chance to be rolled. Then we compare the rolled number with the chance value of the character. If the rolled value is below this threshold, the event occurs. Just imagine it. If the chance is 0, there's no such outcome that the rolled number will be smaller than 0. On the other end, if the chance value is 100, the rolled value will always be smaller than that. That's my simple solution for rolling events. Now we can call this evade inside the attack method. If true, we should print some stuff to the screen, then return without dealing the image. Now let's try it out. Alright, working well. On to the next one. We could do something similar for critical hits as well, but we're gonna shake it up a little bit to modify the image right away. So let's create a dealCrit method that starts like the evade, but it needs the image as the parameter and it will return it as well. If the critical hit is scored, we can print it to the console and return the double of the base image. Otherwise, we return the base image unmodified. Of course, if you want to follow the previous pattern, you could separate this method further like so. Both of them works well. Of course, don't forget to call this method. Pass the base image and forward the return value to the getImage method. Now if we try this, we should see critical hits popping up. Cool. The next feature is the armor. In my case, it's not really RNG, but I show you my approach and I'll leave the rest to your creativity. If you have a cool idea for armor, be sure to share it with me in the comments. In my imagination, the armor is used to reduce incoming damage by some value, so we can withdraw the armor of the target from the critical damage. This will be the final damage. If the armor is higher than the crit damage, This would be a negative value. We can avoid this with the max function. In such a case, the damage will be 0. This damage will be forwarded to the getDamage method. Now we should see some low damage here and there. Just as we expected. Our final RNG feature for today is maybe the most exciting one: counterattack. In this scenario, countering depends on 3 things: if the target is alive, if it rolled a counter, and if the triggering attack is not a counter itself. The first step is to create a similar method like the evade. Simple. This will tell us by RNG if the target can counter or not. The next one is to be able to attack in 2 different ways. This is as simple as adding a new parameter to the method with a default false value, meaning that we don't counter until we say so. Now let's actually call this counterattack. At the end of the attack method, let's put the following. If this is not a counterattack already, and the target is alive, and the target rolled a counter, then print it to the screen and let the target attack the attacker with isCounter set to true. And that's it basically. Let's see this all in action. As you can see, our battle framework is now more complex and the fights are diverse, as they should be for the maximum amount of fun. I have one last challenge for you today. Let's take a look at these rolling methods. They all look the same, right? The only difference between them is the chance attribute that we compare them to. I mean, if you only have 3 of these methods, it's fine. But what if you want to expand the idea and later you have like 10 such methods? It's quite frantic. So I want you to pause the video and come up with a solution that can replace all of these methods and work just as we expected. Now, the solution is pretty simple. We want to create a new method called roll event, and it only needs a number parameter, then it returns a boolean value. The pattern is exactly the same as before, with the difference that we compare the rolled value to the argument we passed. With this, we can replace all the rolling methods if we wanted to. Of course, we would sacrifice a bit of readability for this, so it's always important to consider the benefits of each approach. And that's it for today. I hope this video was a worth it follow-up for my classes tutorial. We'll see. Thanks a lot for joining today. Let me know if you leveled up by sharing your thoughts and reactions with me. If you want to see more, feel free to subscribe. Signing off for now. Stay safe and take care.